Okay, a couple questions to review for your quiz, which we will take this week. So, if you remember what we've done in 3-4 so far, we really talked about what is a polynomial, and then really what are some operations on them: adding, subtracting, multiply, dividing, and factoring. Okay. So, if we look at these first two questions, which of these is a polynomial? So, if we look at the first one, 8x squared minus 7x plus 17 divided by the square root of x. This is not a polynomial. For a couple reasons. One, there is division, which we cannot have because polynomials are always products, and there is also a square root. So both of those make that not a polynomial expression. So if we look at the one on the right, this one is a polynomial because it is just a product of numbers and variables in each term. It is a 4-term polynomial because there are 4 terms, and the degree would be 5 because the highest power is 5. Okay, so let's look at some operations on polynomials, and then it also says, remember, to state the degree of our final polynomial. So this first one is addition. Now I know it's addition because there is an addition sign. A lot of people will try to FOIL this or multiply it, but be very careful if there is an addition sign. So when you're adding, you're simply adding like terms. So I'm going to look for anything that has the same variables and same power. So in this case, I start with an 8x to the 6, which I do not see any other x to the 6. So I'll just keep it 8x to the 6. I see 1 power of x to the 5th here, so I could put that with just itself, so I'll just put 4x to the 5th. For the 4th power, I see 2 terms that have x to the 4th, one there and one there. So 4x to the 4th and negative x to the 4th will be positive 3x to the 4th. So those are done. We've done these. So there's only 1 to the 3rd power, so I'll just bring that down. And likewise, only 1 second degree power, so I'll bring that down. Oops. And then for the linear terms, we have 2x and we have 7, so that's simply 9x. And then the numbers negative 7 and negative 8 is negative 15. So you get this huge polynomial just by adding like terms. So let's look at the second one. This one is subtraction because we have the subtraction sign. So the easiest way to do subtraction, recall, is we will turn this to addition. So I'll write the first polynomial, but I'll turn this to addition of a negative value. Because we know how to add, we just add like terms. So what I'll do with this negative is I will distribute it to all these terms. So this will leave me with 3x squared minus 6x plus 2 plus the negative just switches the sign, so this becomes negative 5x squared plus 7x and minus 8. Now I'll simply combine like terms as I did before. So I have the x squareds here. 3 and negative 2 will give me, 3 and negative 5 will give me negative 2, x squared. Negative 6x plus 7x will give me just positive 1x. And positive 2 plus negative 8 will give me negative 6. So my degree is 2. So degree 2, in this case it is a trinomial because there are 3 terms at the end. Okay, let's look at a multiplication problem. This multiplication problem is a trinomial times a binomial. And if we recall, we'll simply multiply each term in 1 to the other. So I'll take the smaller one and I'll take all of its terms multiplied to the bigger one. So 4x times all of those. And then I will do negative 3 times those terms again. So I have 4x times 3x squared, which is 12 x to the third. Remember, you add the exponents only when multiplying. Minus 4x squared. And then minus 4x. Plus, now I'll do the negative 3 to everything, so that'll be negative 9x squared, positive 3x, and positive 3. And now I'll simply just put together some like terms, which in this case would be the squares and the first degree terms. So 12x cubed stays. Negative 4 to negative 9 is negative 13x squared. Negative 4x plus 3x is negative 1x, and then plus 3. So this turns out to be a degree 3. In this case, it would be a 4-term polynomial, because there are 4 terms. Okay, our last operation is division, which we did synthetically if what we were dividing by, our divisor, just had one thing, which it does in this case, so we can divide this synthetically. So I'll draw my synthetic division box. On the outside I'll put a 2. Remember, it's always what would make this whatever would make this guy right here 0, and 2 minus 2 makes that 0. So I put a 2. Then the numbers on the inside, I'll put a 4, a 0, a negative 1, and a 2. Recall I put a 0 because there's no x squared term. There's a cube, which is here, no square, first degree, and constant. So now I'll do my division. I'll bring down my 4. 2 times 4 is 8. 0 plus 8 is 8. 2 times 8 is 16. Add those together, I get 15. 2 times 15 is 30. And 32, which is my remainder. So how I'll write my final answer, since this was degree 3, my answer always starts one less, so it will be degree 2. 4x squared plus 8x plus 15. The 32 is my remainder, so I'll write this as 32 divided by x minus 2. Okay, let's look at some of these factoring problems, which we spent kind of the last part of the sections on. So it should kind of be the most familiar. So we'll look at this first one. The first thing I'll look for is the greatest common factor, which this one definitely has, because I know the terms 6 and 8 definitely can both divide by 2. If I look at the x's, one has 3 and one has 2, so I can take 2 out of both. And for y's, the first has 1 and the second has 5, so I can take a y out. So let's take that GCF out first and see what we're left with. So if I take 2x squared y out, I have a factor of 4 left for the first term. I took out 2 of the 3 x's, so I have 1 x left. And I took the only y out, so I just have 4x left. I took a factor of 2 out of negative 6, so I'll have a 3. I took both x's out, so they're gone. And I took one of the 5 y's out, so I'll have y to the 4th left. Now if I look at what's left over in my parentheses, that is a binomial which sometimes factors, but this time it does not because it's not difference of squares, it's not difference or sum of cubes, and there's only 2 terms. So this is my answer. So always look for that GCF first in all these problems. Okay, the second one, after looking for a GCF, which I see there is no factor that comes out of all 4 terms, I figure out, okay, how can I do 4-term factoring? Well, that's with grouping. So I put a set of parentheses around each, and I take GCFs out of both of those parentheses. So out of the first 2, I can take an A. So if I take a factor of A out, I'm left with y minus 3. So the second ones, I have negative 3y and 9, which obviously both divide by 9, but I'm actually going to, or by 3, pardon me, I'm actually going to take out negative 3, because we always like to make that first term positive. So if I take out negative 3, I'm going to end up with y minus 3. And now I have these two guys that match. So to do that, that becomes one of my factors. The ones that match become one of my factors, so y minus 3. And then the other factors are just the things that we took out. So a minus 3. So those are my factors. That's my factorization. Okay, 8 and 9 kind of talk about our trinomial factoring, where we did our magic box or our rectangle or X, whatever you want to call it. So I will put, there's no GCF, always look for that. So I'll make my box here. I'll put my first term, which is x squared, there, and my last term, which is negative 20, there. So now we just got to figure out the terms to put in the other boxes and then do some GCF factoring. So we said multiply the first and last number, which gives us negative 20. So now we're trying to figure two numbers that multiply to negative 20. So multiply to this, but have to add to negative 8. And if you think about it, not a very tricky pair. It would be negative 10 and positive 2. Those multiply to negative 20. Those add to negative 8. So I'll put those in these boxes. Doesn't matter which goes where. And then I'll start taking out some GCFs. So the first row, I could take out an x. The second row, I could take out a 2. The first column, I could take out an x. And the second column, I could take out a 10. But again, because that first term is negative 10, let's go ahead and take out negative 10. So now I have my factors. They're just the things that are on the top row and the bottom or left column. So x plus 2 and x minus 10. I think you'll find when you practice these enough, they actually do start to become pretty second nature. So let's look at number 9, a very similar problem. There is no GCF. A little trickier because the first number is not 1, it's 12 in this case. But the same concept really will apply. So here is my box. I'll put my 12x squared there. I'll put my minus 4 here. So 12 times negative 4 is negative 48. So I have to think things that multiply to negative 48 but add to negative 13. A little harder in this case, but it turns out it's negative 16 and positive 3. So I'll put negative 16x here, 3x here. Don't forget to put the x on our numbers. So the first row, I could take out a 4 and an x. Second row, 3x and negative 4. I really can't take anything out, so I'll just put a 1. First column, 12 and 3, I could take out a 3, and then I could take out 1x. And then 16, negative 16x and negative 4, both divide by 4, and I'll take out again the negative 4 because that first term is negative. So there are my factors. 3x minus 4, 4x minus 1. Pardon me, 4x plus 1. And again, you can FOIL to check these to make sure it works. It does. Very, very cool technique. A lot of different ways to do this, but this, I think, is definitely the easiest. So let's move to our last two problems. These are just our binomial special patterns. The first one we have here is the difference of squares. Not very difficult to see why it's squares because they are obviously a z squared. And 81 is a perfect square because it's 9 times 9. So this is 9z and 9z and 4 and 4. So the factorization is very simple. It's just 9z minus 4, 9z plus 4. So difference of squares is a really nice factoring pattern. When you recognize it's a difference, and again, it does have to be a difference. Once you recognize that, you just simply have to follow the pattern, which we know is a plus b, a minus b. Okay, let's look at the last one. This one has two terms, no GCF. So I'm thinking cubes, and it is, and it has an x cubed, which is a good hint. X cubed is a cube because it's x times x times x. 64 is a cube because it's 4 times 4 times 4. So if we recall the formula for sum of cubes, and it is a sum, and you can do sum or difference for cubes, just not squares. This factors as a minus b, a squared minus ab plus b squared. So in our case, our a is just simply x, and our b is simply 4. So we'll just plug those in and have our factorization. So x plus 4, oops, this is plus, sorry, it is the sum of cubes. A squared, which is x squared, minus ab, so that's x times 4, or I will say 4x, plus b squared, which is 4 squared, which is 16. And that is the factorization. Never worry about this last guy, it will not factor in the real numbers. So that's it, a quick review for your quiz.